Everybody had a chance to refresh their drinks, go to the bathroom, and do whatever else they had to do. Our distinguished panel is up here, and they're going to engage in today's conversation, and it's going to be conducted by Curt. The other thing that we ask for is audience participation, so if you have any questions, please feel free to raise your hand and engage. Curt will make sure he comes over and act like Phil Donahue and hand you the microphone and let you speak.
Thank you, Brian.
Oh, one more plug. Where's Dr. Adnan? Oh, Anand, you're gonna come up here too. You're on the spot. So we're gonna put you up here. There was a question during the break on whether or not there were internship opportunities for current students. So would you like to field that right now, or? Okay.
IBM Research hires a lot of interns. But typically the interns are either very near doctoral students who are very near completion, or actually have completed their PhD and are doing some sort of a industry internship before they actually get into a job, like a postdoctoral fellow. So that's the typical route. And then we do also hire summer students. But again, typically what ends up happening, at least what I've seen on average, is that the summer students are usually have completed their masters and are working towards their doctorate.
Thank you. All right, without further ado, Curt needs some time in the spotlight, so let's give Curt the microphone.
Less time in the spotlight for me, the better. So, excellent presentation, Dr. Paul. A lot of ground was covered. One of the things, given the breadth that we saw with the capabilities of Watson, along down the left-hand side of the slide there, kind of generates the question of what does a user interface for this tend to look like? I mean, you almost need a hologram going to the Star Trek parody immediately of the standing there stating, what is the nature of your medical emergency. So maybe we could start off with what people think might the user interface for this sort of thing look like.
Oh, okay. For the medical application, actually, what we've done is we have created a very, it's just the beginning of our work, which has essentially taken, about 4 to 6 months now. But we actually developed an iPad-based user interface, a very simple one, just to show, what the art of the possible is. Of course, a lot more things have to be developed after that. But, our goal is, the simpler it is to use, the better it is. And it looks like a lot of people nowadays are walking around with iPads. Most doctors are actually, many doctors are, I should say. And so that seemed to be a fairly simple thing to do.
Yeah, so I think you're really right that these portable devices are the way to go. So even just people's iPhones, if you've seen the ads for the new iPhone 4S, one of the big things they're selling is this Siri application that they have where you can talk into your phone and ask it a question, and it'll tell you where the best restaurant nearby is or who you should hire as a carpenter. So I think one of the really interesting things about these huge, powerful systems that we're building is that they're accessible through remote devices. So even something as, that's not particularly powerful, it's sort of amazing what I can do on this phone, but compared to the full Watson system, it's pretty tiny. But it can interact with these huge systems and allow us to access those in new ways, which is pretty amazing.
I'm not sure what we're doing.
Just commenting on
do we get a chance to offer some comments of our own?
Sure.
What's interesting to me is where artificial intelligence is going. Watson is a wonderful example of artificial intelligence, but there's so much of it around that it's going to become mainstream. I think in about 10 or 15 years. I run a little project called TechCast where we forecast breakthroughs in all fields. And here are some of the things that we have listed. I passed out our forecast for what we call weak AI, because general AI, I think, is something else. But AI that can handle well-structured problems like this, I think, is imminent. It's here. And examples are the Siri system, a personal assistant. I think that's going to become prevalent. It's going to be the way we make sense out of this avalanche of information that is inundating us. These assistants are going to know everything we do, how we make decisions, and they're going to take over tasks when we ask them to, like a real assistant. Or think of GPS navigation systems. That problem has been solved, the problem getting from point A to point B. Intelligent cars, the DARPA Grand Challenge project, where they took cars through a desert setting and then an urban setting. Half dozen cars made it, and Google has a project. We're going to see self-driving cars before not too long. Robots are going to incorporate all of this. They increasingly do that now. Anand mentioned IBM's stream computing. I'm more impressed with your neurosynaptic chips. I mean, that's really brilliant. Chips that simulate the human synapses so that you could create systems that operate like the human brain. And there's just so much of this. The intelligent search systems like Wolfram Alpha. It's just appearing all around us. So that's what really impresses me. We are entering now, I think, a world where everything gets intelligent. All the machines become smart, and they do what we ask them to, and they take over the routine mental work. That's really quite an accomplishment. You think that's an accurate statement? Yeah.
And you hit at some of the points that we are seeing as well, and
Yeah. In about 10, 15 years, I think. Mainstream.
I think the other thing is about these particular type of systems is, even though it sounds like it's not an intelligent system, I call them brute force systems, because what you're really doing is taking a supreme amount of compute power to go through very quickly a large amount of data which we're all drowning in, and there's no way humans can sort through all the data that's there. And of course, the other thing that these type of systems are good for is for narrowing down the data that's specifically related to you and maybe your surroundings. So even though it may know all the best restaurants in the world to go to, when I live in Annandale, I don't care about the best restaurant in India. I want to know what the best restaurant is within 5 minutes of where I am at the time. And it can find all that stuff for you. But all that stuff is just a way of accelerating what you kind of can do anyway. But because of the large amounts of data, you need the computing power to do it in a way in a time frame that's reasonable. What's more important and interesting to me is what's going to be happening in the future when you start expanding the capability that companies like IBM Research and so forth are doing, is tying in the newer technologies that allow you to not just deal with what you know, but to draw inferences between things which are not necessarily linked together in the database, so that one can make assumptions that humans do, that if I see a lot of something here and a lot of something over here, I can somehow, because of the way they interact, draw a conclusion that somehow they're related. The systems today aren't doing that yet, but that's going to be the next step that we're going to start seeing, I think, is that these isolated pieces of data are going to be able to be utilized to draw inferences from that data that you wouldn't be able to make, and that humans might not be able to make because they don't understand the pieces and how they interact.
So if I may give you also my perspective on how Watson can work for us. So I'm on the scientific computing side, so we've been using much more powerful computers than Watson to do scientific computation. So we use the Blue Gene P and now the Blue Gene Q, for example, where you utilize half a million cores together to solve a problem. So the problems we are solving are primarily related to medicine. So we're trying to model a couple of heartbeats of the human heart with an artificial valve implanted, and we're trying to then estimate what is the risk of thrombosis. So which is a very difficult task, because thrombosis is something that happens over thousands of heartbeats, so we can only simulate just a few. Of course, the simulations are so complex, and we will generate this couple of heartbeats will be half petabyte of data. that we will then have somehow to sort through and try to understand how our hemolysis model works, how our platelet models come in, and how we can predict with some certainty that this particular implantable device is less prone to thrombosis than another one, which is finally what every medical doctor will be interested in at the end of the company that is developing the product. So systems that, like Watson, that can bring some intelligence into the analysis of this data are really crucial in scientific discovery and accelerating scientific discovery, because it's impossible for even a group of researchers or researchers spread all around the world that have access to this database to be able to make sense of these highly complex data structures and data. So this, I think, is where what the contribution of artificial intelligence, Watson, or data mining, there are lots of different names depending on which hat you're wearing, if you're a computer scientist, applied mathematician.
Right.
But the truth of the matter is that data is going to be the next, I think, big problem that we need to solve, since it looks like with petascale computing, which we're right now, and we have scalable codes that can achieve petascale performance, or exascale in the near future. Then at the exascale we'll have even more problems in making sense of these humongous data sets that we will be producing. So that's kind of the different angle from the scientific computing and scientific discovery aspect. I think will be really valuable in our fields.
So, questions from the audience?
Thanks, Curt. So my question is, I guess, for anyone on the panel who thinks they can answer it. I think that given our location here in Washington, D.C., we would be remiss if we don't think about policymakers and the regulatory agencies here in town that sort of set the framework for technology and technology moving forward. So my question for you is, for technologies like Watson and other emerging technologies, what is the government and policymakers doing, or what are they not doing, that can help or hinder the creation and promotion of these technologies?
Also, I don't have a complete answer to this. It's a good question. I mean, one thing that's really obvious from the talk about what Watson can do of connecting data that's in completely different sources, completely different contexts. Clearly, this can lead to huge privacy concerns about connecting people's medical records with their driving history, with their whatever else. So there certainly needs to be a lot of thought about the policies around how privacy and certainly the security of this type of data and how the processing of the data is performed is definitely going to be an important issue going forward.
Well, I have an immediate thought, and that is, gosh, we have just horrible IT infrastructure in this country. I heard we've all known that, for instance, our broadband is kind of terrible. But I heard the other day that it ranks 24th in the world, our broadband, 24th. How can you use intelligent, high bandwidth systems with such terrible broadband? You've got to have bandwidth to do these intelligent things. I would think one of the first things that this federal government should do is to create some kind of an incentive program or something to get the IT providers to increase bandwidth by a factor of like 100. Other nations, the Japanese, the Koreans, have like 20 times the bandwidth that we have. And you can't do intelligent things without bandwidth.
My take is on what our governments are not doing is that I mean, they are doing it slowly, but perhaps they need to accelerate it a lot more. Evaluate, where their research dollars are going, and what kinds of analyses and what kinds of research projects need to be undertaken. And I'm not saying, I mean, there are a lot of organizations around the U.S. who are doing research, and they're doing very good research. So I think the way, we've talked with and described our work with to several government agencies as well. So they are slowly, understanding the need for this. From our selfish point of view, I guess not fast enough, and I think so. Maybe they should look at the benefits that big data analytics can actually provide, and adopt it faster, I think.
So one more question from back here.
Yes, I was wondering if anyone on the panel could weigh in on the Ray Kurzweil, Bill Joy debate of old, that with computing power increasing so quickly and within a few years perhaps surpassing human intelligence, perhaps even reaching consciousness, would that be a good thing, a bad thing? Will it be controllable? And will it happen?
I've got thoughts about that. Sure. I think that's really a great question. Where's all this going? Now, I think people like Kurzweil, who, and most physical scientists, I think, feel the same way, that there's really no good reason why computer power couldn't surpass human intelligence. That's the premise. I think that's based on a fallacy, and the fallacy is that the human brain that human thought is just processing information. I don't think that's true. A lot more is going on at higher levels of cognition, things like emotion and awareness and values and choices and all of that stuff that is the essence of being human. And I think the physical scientists miss that. I don't think the machines are going to get, they may get smarter than us in a literal sense, but they won't have the intelligence, the broad intelligence that humans have. And my guess as to what's going to happen is that as we're going to automate routine human thought. I think that's true. All of these advances in artificial intelligence that I mentioned are doing that, and over the next 10 or 20 years, it's going to be accomplished. Just the way we've automated agriculture and then manufacturing, then services, now we're automating knowledge. And so it raises the question, what do people do after we automate routine knowledge? And I think what's going to happen is going to make us realize the unique qualities of being human. The creativity, the initiative, the entrepreneurship, the values, the intuition, all of that stuff, I think is going to come to the fore. We're going to increasingly value the unique qualities of people as opposed to the machines. And we're going to need those things to solve these enormous problems out there. Climate change and cybersecurity and peak energy and all of that. Globalization is creating an enormous challenge for the world, unprecedented. So there's no lack of work for people to do. It's going to take these higher order skills to do it well. So I think that's really a great issue. It's a very crucial issue.
So I'm sort of obsessing over number 3, parallel hypothesis, generation and confidence scoring. And trying to fold it into what was mentioned before, and using infinitely more powerful computers to process large data sets. And one of the things that I know, being in business, we get fronted with problems, and then we don't actually know what the problem is, and we don't ultimately know what the solution is, and then we run through iterations on trying to figure out what the problem and the solution is. So rather than just a discrete question posed through natural language, is there any way to derive derivative sets of hypotheses that will allow you to spur innovation, an innovation based off of a concept, and finding those white spaces? And how could something like Watson be used to spur innovation?
Yeah, that's a great question, and in fact, we've been thinking about it, not necessarily doing anything about it yet. But, how can we create systems that develop models of their own, as opposed to you prescribing a model to a system and then let the system sort of use that broad-based model to do various things? How can you develop a system where, you don't know what to do, so you don't know what to ask, and let the system ask a series of questions and become intelligent, and then come up with some sort of an answer, even though you didn't know, what you were looking for in the beginning. And so, you know, we've been working with several agencies, and you know, the idea is where you know, they're on a parallel path where they don't know whether they have missed something or not. Okay, they have prescribed something, they've developed something, but they don't know whether they have missed a certain major crucial factor that should be incorporated. So, you know, how can a system be looking sort of over your shoulder, if you would, to figure out, you know, what is it that you're doing, and tell you that, oops, that's where you made a mistake there. Do you really want to do that, or do you want to consider these three things as well? So let the system develop models for its, you know, and tell you, you know, ultimately you as the decision maker understand whether that's right or wrong.
The way Watson develops hypotheses.
Right.
Right.
I think there was a clue in his talk also where he indicated that innovation comes through disruptive technologies. So the question then you have to ask yourself is, what causes disruptive technologies to occur? One thought that I've had for quite a while and have written several articles on is that disruptive technologies actually occur when you get trends that intersect, and those trends that are disparate and they intersect allows things to interact in a multidisciplinary way, which they couldn't before those trends intersected, which allows you to get disruptive thought process going, which allow you then to get the disruptive technologies development. So if you use the computational capability and the information utilization of systems like Watson to do predictive trend analysis, which I couldn't do before, which allows you to develop those disruptive technologies.
As technology advances, we become more interconnected, and I mean, that's great and awesome, but at the same time, what measures are being taken to kind of account for the vulnerability that places us in, whether it be medical systems or communication systems, as the example of Iran's nuclear facility being infiltrated, and the concern that that could happen just as easily to us.
I'll take a first crack at it. I mean, you know, that's a real concern, and you know that you know, if you have systems, then you know, you need to look at how good or bad their security you know, systems are in place, and you know, that's true. And in the case of DeepQA and Watson, that wasn't a big concern for us because, you know, it wasn't connected to anything. It was a self. So unless somebody actually broke into our system, you know, data center physically, you know, they couldn't do any harm. But you know, I mean, this whole area of you talked about, you know, interconnected people. You know, also, you know, the whole area of you know, running applications and data centers on the cloud. So how secure are they? And you know, there's a lot of effort going on in that space. And the question also is that do the people perceive the systems to be safe enough or not? That's a big part of the challenge that has to be overcome, other than the technology bit of it as well.
Yeah, just to expand on the idea of the fact that we're sharing more and more of our personal information with these cloud web applications. All of our email is on Gmail, our personal calendars are up there, our photos. It really is a concern about whether those individual companies are keeping their data secure. Are they separating, you know, my data from somebody else's within their own service? Are they exposing data outside of their service? There definitely are huge challenges here, and right now we're really just sort of trusting these companies, and hopefully that's okay, but you know, clearly there needs to be a lot more done to really make these companies prove that they're enforcing certain levels of security and privacy with the data that we're sharing.
Well, as you would wall these areas off, getting back to the security part, you also wind up limiting where the intersects are going to occur between the different technology streams. So you'll wind up limiting the innovation that is possible, that could possibly happen. You want to address how you wind up making those choices, or?
So if I understand your question correctly, it is you're saying that with all these limitations, it also limits innovation at the intersection of these technologies. Right. So I think that probably is a true statement, that it does limit limit innovations, because if the government, as an example, as a security setting body, for example, or a standard setting body, sets certain standards which have evolved through a series of processes that have gone on either within the governments or through private organizations. As we evaluate those and as we try to implement those, certainly the intersection of technologies is a key area where we need to look at. And I think, as was pointed out earlier, when we are looking at disruptions, in many cases, the disruptions are not necessarily on an individual technology basis, but the disruptions are actually on a combined basis. For example, we don't think that the development of deep QA was, there were disruptions in the individual technologies, but the way it was all brought together was a big disruption. We did look at all the various standards that people have developed over the years to figure out how we can live within those, and perhaps in many cases, even enhance those standards. But that is something that needs to be evaluated.
I think we've got time for one more question.
Did Watson cheat by not having any latency for the neuromuscular triggering of the buzzer? It's just a yes or no question.
Instantaneous response time.
Actually, Watson, according to what's written, delayed up to 3 seconds before it answered.
Oh, okay.
Yeah. And in fact, it was not just that, it was an actual physical buzzer that went through. Yes, so Watson didn't have a blood and flesh, thumb, but it had a mechanical device which was triggered and which buzzed in.
So same thing.
Yeah.
Neuroskeleton.
My question is around social responsibility. One of the interesting things you talk about, technological disruptions, but often that leads to a social disruption. An interesting thing about Watson, you mentioned one of the applications is call centers, for instance. So I can see IBM saving a lot of money by, for instance, firing a bunch of call center people. I'm not saying that's really good or bad, but another panelist talked about we would be respecting the humanness or the human quality, but we don't have a history of respecting each other's humanity. So, as we look forward, what kind of social responsibility might we have to take in terms of dealing with all these people that will be displaced?
Well, social responsibilities are an interesting area. And one thing that people need to decide within their own conscience is because something is available to be done, do we have to do it? That's kind of what you're asking. Just because we can do it, should we do it? And those get into issues that probably group of people you'd get together, you'd come up with twice as many answers as there are people in the group trying to come up with the answers. But in terms of displacing people, I think the thing to remember is that as technology has moved forward, there have been more jobs created by technology than have been eliminated in terms of the gross activity of humankind. Now, there have been displacements in terms of what people do. There aren't a lot of farmers left in the world, for example, at least in the US. But all those farmers either kept farming until they died, or they became something else. They went and worked in a grocery store or whatever they did. My father grew up as a tenant farmer. he never had an education. He went to school, 3 months a year through the 8th grade, but he had 6 restaurants when he died. And so farming was he was displaced from farming, but he got trained in something else. And so education and training are things from a social responsibility, and an educational institution like George Washington University tries to fit this bill, is train people for how they can understand what they're doing. I can tell you from a fact that, after getting a PhD, I've done as much work every 5 years getting another PhD equivalent. You just don't get the degree because you don't go pay the money to some institution to give it to you. But if you stop growing and stop learning, you will be displaced, and you can become homeless just because you don't want to expend the effort to learn something new.
Well, I haven't thought about that. I think you're right. The things like call centers and all of these intelligence systems, they're always going to be clunky, and they're always going to not serve the needs of people. People are going to get exasperated. No, I didn't. No, I want this. People start getting angry. They start insisting, but the machines don't know that. And I think the solution is to have human backup systems, and some good companies do that. That if people get exasperated with a call-in system, they just say, "Can I speak to an agent?" And those humans have to be available to pick up where the machines fail.
And that's my first answer, is always press 0. I want a human.
Yeah, that's right. That's right.
No, they are smarter than that now. They don't let you do that.
Okay, we do have one other question, and then we'll start with closing remarks.
This was just to build up on the last thing you said. So what happens when systems like Watson become good enough to teach math, which is, compared to philosophy, relatively easy to teach to small children, to college students? It's a process. You do this, this, this. And then up until that point, start teaching our doctors and even becoming our doctors. Is that going to displace even more jobs? Like, if half the professionals have to change to something else, is there a lot of implication in that? Or, like you said, that they can change to something else, but when half the jobs are being taken up by robots, which I think everyone's been fearing for a long time, but I don't even know how to phrase my question after I say that.
Well, for example, there aren't many coders around today who actually do coding. A lot of the higher level language have displaced all the early programmers who wrote in assembly language. You don't find many people who program in assembly language anymore. Take integrated computing, integrated chips rather. There aren't a whole lot of people who know how to do the basics part of those, because all of those things now are done by machines. And so everything else is moving to a higher level. People program, yeah, but they program at a higher level language. In the future, it wouldn't be unreasonable to say, much like you address Watson in natural language, I want to write a program, and I just tell the computer what I want it to do, and it generates a program to do it.
Okay. So closing remarks on where the technology is going, how it can help us in both business and government.
What we feel, by the way, great set of questions and answers and discussion here that we just had. There are many valid points, but to this, but the last point that was made about, getting on to higher level things, I think that's really where the whole, area is going. What we feel is that we are not creating systems that are going to replace the areas where we are working in. For example, we're not in the business of or even looking for replacing doctors, and that you go into a doctor's office and you're seen by a robot. We're not looking at that at all. But what we are saying is that using such knowledge systems, one can enhance the knowledge of whoever the the actual doctor is, or whoever else is doing the teaching, or whoever else is doing the programming. Certain functions might go away. Yes, that's true. For example, if you are looking at, or maybe not go away, but at least get reduced. For example, in the whole business of case law, as an example, can you suck up the entire case law that is out there, and then rather than have the junior legal associates work hours and hours and hours looking for stuff within those case laws, can it come up fairly quickly for you, so that those junior associates can now do some real work as opposed to looking at journals and case laws. So the whole idea is how can these systems help you gain knowledge faster and make better decisions.